Let's talk about confidential computing. You want to use public cloud services to minimize upfront costs or maybe to rapidly develop cloud-native applications. But these applications are going to deal with confidential information. Not only do you want to encrypt the storage used, but you also want to prevent any cloud operations teams from getting access to that data, even if they've got physical access to the data centers themselves. One way that we enable this is with a set of technologies that we call IBM Cloud HyperProtect services. Hi, I'm Chris Poole. I'm a Senior Solutions Architect in the IBM HyperProtect team. In this video, I'm going to talk a little bit about what you can do to ensure your customers' data stays confidential, and then I'll introduce a simple application that demonstrates a basic use case, and I'll show you how it works. Now, part of an overall solution to protect your data is to encrypt it. But now you've transformed the problem into the problem of how do I secure my keys? One way to help resolve this issue is to employ an HSM, a hardware security module. This is a physical card, a small lockdown computer that's been engineered to be tamper resistant. You can store your keys in there and nobody, even with physical access to the system, is going to have access to your data or your keys. The HyperProtect variant of this, your own discrete slice of an HSM coupled with a secured software stack, is called the IBM Cloud HyperProtect Crypto Services. Before making use of HSMs, they have to be initialized with a master key, which has got ultimate trust and power. Once done, the HSM is primed for use. The crypto service and the HSM it uses is a little different from others on the market in that it has the model of keep your own key, not just bring your own key. What this means is that we never see your key data during the initialization process, so you don't have to extend your trust model. But it also means that you have to go through this initialization process yourself that we call the key ceremony. Once initialized, the HSM can store root keys or standard keys, which in turn can be used with technologies like envelope encryption to be able to protect your client's data in object storage, in databases, or things like TLS certificates. Let's do the key ceremony now. One popular way of doing this is with our trusted key entry command line interface, but another way is to use smart cards and a smart card reader. These cards in turn can be used to store master key data in them across multiple cards so that you can take the different cards and place them securely in different locations and have them owned by different trusted people within your organization. Let's use these smart cards and initialize the HSM I'm going to use for the demo. First, let's do the first card. For brevity, I'm not showing the full process here. Once that's done, I can repeat this whole step with another card or another few cards. To be able to split the master key across these different devices. I don't need these cards for day-to-day use of the HSM, only for the initialization process and for any future administration. So I can take these cards, give them to different trusted people in my organization, and have them securely store them at places like bank vaults. Then later on, if I want to do any administration of the HSM, I can bring the people and the cards back together so that we can perform these operations. So the initialization has been done. Now let's talk about the demo. In my organization, I've got different teams who each own their own set of cloud-native applications. For cost reduction, I want them to all be able to write to a consolidated database. But I want to be able to isolate the data between the different teams, so one team can't read the data from another team. So what I'm going to do here in a very simple way is to have some different applications take some input data and encrypt it with a different key, one per team, before storing it in the shared database. This database, by the way, is another of the HyperProtect services. The confidentiality requirements obviously transfer across to the long-term data storage. So we have database flavors that also run within secure enclaves. So the data and the logs are encrypted and there's no underlying machine access. So let's deploy the applications. I've containerized them into a virtual server instance in, you guessed it, another secure enclave that we call HyperProtect Virtual Servers. In this way, the runtime data is also protected, and only I, with the SSH key injected at service creation time, can access the applications. Let's stand up a Mongo database instance on the back end, then SSH into the virtual server, start up the applications, and connect it all together. So the data flow is simple. The applications expose a web UI, they receive that information, make use of a key pulled from the crypto service at runtime to encrypt the data, before storing it in a database on the back end. Let's add some data and use the applications. So I'm entering some data here, storing it in the database, and then I can go to another screen and confirm that I can retrieve that data from the database using the key it has in memory to decrypt the data within the application runtime. It's all end-to-end encrypted during transport and at rest. Let's switch teams, meaning we'll pull a different key from the crypto service, a different application, and let's store that data before checking we can read it. We can, but now let's try to read the data from the first team's application. It's encrypted, we can't read it. We've consolidated our data pool, but we've still kept the teams isolated. So these are the IBM Cloud HyperProtect services, helping my data to stay confidential. So let's summarize what we've just done here. We deployed a secured virtual server, we created a lockdown database, and we created an instance of the HyperProtect crypto service, and then initialized its HSM. Using these three different services, we deployed an application that's able to take data from the end user, encrypt that using different keys for different teams from the crypto service, before pushing that encrypted data into a consolidated database. In turn, this creates a cohesive, confidential computing platform on IBM Cloud. Thank you for watching. If you've got any questions, please drop us a line below. If you want to see more videos like this in the future, please like and subscribe. And don't forget, if you want to learn more about the IBM Cloud HyperProtect services, please check out the links below.